Hello, hi, it's Henry the computer guy, and you're welcome to our lesson number 44. And in today's lesson, we are actually going to be seeing some of the examples and some of the exercises you're going to be trying for me. How can we actually convert some storage units to other storage units? For example, you're having MBs or you have GBs, you want to convert them to other storage units. So we have the first question, and they're actually telling us that how many bits are required to store the following words. So they have given us the first word, which is Henry. How many bits are in this? But remember, when we come to our word, these are bytes. But remember, each byte consists of 88 bits. So that means that we're going to count our number of bytes here. We multiply them times 8. So let's have our solution. So they're telling us that 1 byte consists of 8 or equals to 8 bits. Then what about the ones we have counted from that word? And we have counted, they have been 5. So what about the 5 bytes? They will give us what we don't know. So that means that we are going to be making a cross multiplication. 5 goes with 8 and y goes with 1. So that means that we shall have our y as 5 times 8, giving us our answer as the 40 bits. So that is very simple. You just have to know what you're looking for, then you cross multiply and do the calculation as simple as that. So you're going to be trying for me some of these. So they're telling us that how many bits are contained in the following words. And we have the first word, which is computing. We have boys' school, that is degrees Celsius. We have your neighbor. We have how many bytes are in 16 bits. Now that means that this one is changed. This one was asking for bits, this one is asking for bytes. So we continue, and I've already put for you the answers. That means that you can mark yourself. Let's first of all try them out and see. For example, if I look for what we call a sticky note to, let's say, write something aside when you're seeing. Let's say I've gotten this. Let me just remove this. So we are beginning with the first one as computing. How many bytes are these? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Are they 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, they are 9. So that means that we have 9 bytes or characters. Are we together? Those are the 9 characters or bytes. But remember, each byte consists of 8 bits. So we shall say that, of course, 1 byte equals to 8 bits. Then when we come down here, what about the 9 that we have counted? 9 bytes will give us, let's say, x. We don't know what we are looking for. That's why we are looking for it, because we don't know. So that means that we are going to cross multiply. So the x is going to be equals to 9 times 8, giving us the answer as x equals to the 72 bits as the answer we have here. That is how we are going to be calculating them. Let's count. Let's make another one and see if I'm to close this one and I get another one. So let's calculate number part B. Let me also get another sticky note. So it is here. Let me put it just down here and I calculate that number 2. So first of all, we are going to count the number of bytes which are there. So now we shall count 1, 2, 3, 4, then 5, this apostrophe, 6, the space, 7, 8, 9, 10, 11, 12. That means that we are counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 bytes. Are we together? So now all characters. That is what we are having. So when I come down, of course, we know that 1 byte equals to 8 bits. Then when we come to, let's say, the 12 bytes, will give us y, because we don't know that. Of course, we are going to be multiplying cross multiplying. So our y is going to be equals the 12 times the 8, giving us the answer as 90. So y will be equal to 96 bits. Simple as that. So you're going to do for these ones. That means that you will be able to do for me these ones. For example, this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7, and others. So let me try this other last one. So let's get another sticky note again. Come and say, for example, we have it here. So we want to calculate our part E. So we know that they're now asking for how many bytes are in 64 bits. Now they have given us the bits they want us to count or to get the bytes. So we know that one byte consists of 8 bits. Now, what about the ones? That means that they're asking for the bytes, so we don't know them. We call it a question mark, or we can call it an letter. Let's say Q, or any letter. Let's say we call it, letter E. That will give us bytes, of course. These are the bytes we don't know, but we have what we call the 64. The ones we are having as the bits. So that means that we are going to be cross multiplying. So the 8 is going to be, now when we come down here, it is going to be 8 what? 8E, giving us the 60 what? The 64 bits. So for us to get this E, we are going to divide it by 8. So we divide both sides by 8. When I divide both sides by 8, it will be this side by also 8. So this one will also be by 8, so we shall actually be remaining with only E. Because the 8 and 8 will cross, then we remain with 64 divided by 8, which gives us the answer as 8 bytes. That is how we can calculate that. So I think you can try out the others that I've actually not done for you. That is how we can go about it. I think we are good to go. We continue. And we have some other examples or more examples. And they're telling us that question 2, arrange the elements below in terms of their relative sizes in ascending order. So they want you to begin from the smallest going to the biggest. And they have given us question 1. Of course, we have a character, we have a document, we have a page, we have a word, and we have a paragraph. What comes first? Or what is smaller in those ones that we are seeing? So they have not asked you for the number of bits in those words, but when you look at actually them, which comes first than the other? For example, if you're to build a house, what do you do first? You have to get a plot of land. Then let's say you buy the material, then you put the house onto that plot. So that means that one has to come after the other. Of course, let's arrange it and see. If I have a character, let's say I'll begin with a character. Let's say one letter at a time. If I'm writing, let's say my book, for me to write that book, I will begin with the first letter, let's say one letter. So when I combine those different letters, they will have to form what we call a word. When I combine those words, they will have to form what we call a paragraph. Then, after forming a paragraph, they can form the page, the whole page of the document. Then after, it forms the entire document. That is how we are answering it. So it becomes as a character, the word, or characters form words, words form paragraphs, and paragraphs form pages, then pages form the entire document. We continue. They have GB, kilobyte, megabyte, bit, and byte. What comes, or what is smaller there? It's the one we have to begin with. Of course, it has to be the bit. Then we come to the byte, kilobyte, megabyte, gigabyte, as we have seen them already. Then we continue. This is a deer, and this means that you're going to do it yourself. Or I can actually try it for you down here. They're telling us that does a text document with 1 million characters fit onto a 1.4 MB disk? The answer is either yes or no. But you cannot either write the yes or no without proving whether it is right. So what we are going to do, we are going to make a calculation for that. Of course, let's look for what we call our sticky note. and write something down. So they have given us that we have, actually let me make it somehow bigger. So they have given us 1,000 character, 1 million character. Let's write it there. So what does that mean? Remember we said a character is the same as a byte. So we can write it again as bytes. So do we understand it now? Yeah. So they're asking us, do the 1 million byte fit onto a disk of 1.4 MB disk? So we have to prove whether they fit. But actually down here, we know that 1 MB actually equals to 1 million bytes. Equals to 1 million bytes. That is actually 1, but they're asking for us 1.4 MB. So we are going to see what the 1.4 MB represent. We come down. So what about the 1.4 MB they have given us? Actually, this one gives us what we don't know, which is y. So remember, this is MBs, this is bytes. So we have to convert them to the same unit such that we see whether this one can fit onto this one. So that's why we are changing the 1.4 MBs to bytes, such that we see either if the 1 million is bigger or the 1.4 MB is bigger, such that we can prove whether it is right or it is wrong. So that means that we are going to cross multiply our y, giving us down here as y, giving us, let's say if you cross multiply this is going to give us this, then you multiply this and this. So it is going to be 1.4 times the 1 million. So now that means that we have a point here. So we remove 1 0, it takes the point in front. So y is going to actually represent the 14. Let's say add other 5 zeros. 1, 2, 3, 4, 5. That becomes the bytes. So now when you look at this value, this is a 1, let's say 1, 2, 3, 4, 5. So this is 8. So when you look at this value and this one, which one is bigger? Of course, the 1.4 MB disk or bytes are more than the 1 million bytes. Therefore, the answer becomes yes. The 1 million characters can fit onto a 1.4 MB disk. Because we have made or proven it, this one is far bigger than this one. How have we proven that? Because we have changed them to the same units and we looked at which one is bigger than the other. That is it. Very simple. We can continue. I think actually in the next lesson, we shall actually be talking about more of the questions. Now, they're actually telling us that we are going to be converting 20 KBs to bits. We are going to be converting 5120, then 000 bytes to MBs. And we're going to convert a 2 GB to a KB. Then we have the answers also. So I've given you the answers. You can actually help me and try out some of them. Let me do for you the first one. So they want us to convert the 200 KBs to the bits. Actually, when you're converting these units, you have to look at the scale. What do I need and what do I have to use? So now we are going to see, we are saying that we don't have that scale where we have the KB and bits at the same time. So what you are going to do, you're going to get our sticky note and write something down. Let's write something down here and make some calculation and see whether we can have that answer. So we know that 1 KB equals to, let's say, 1,000 bytes. Are we together? Now, what about the 200 KBs? Equals, they will represent what we don't know. Let's say X. That means that we are going to cross multiply to get our x. So our x is going to be equals to, let's say, 200 times the 1000. So our x giving us the 200,000 bytes. I think that is okay. 200 bytes. But remember, these are not the ones that we are having or we are looking for. So we continue. Now we are going to convert the bytes to bits, because we know that 1 byte equals to 8 bits. Are we together? I think we are together. 1 byte consists of this. Now what about the 200,000? Will actually give us, let's say, the y. We don't know it. That means that we are going to cross multiply to get the number of bits that we need. So actually our y below is going to be equals to 8 multiplied times, let's say, the 200,000. So our y actually giving us an answer which is let's say 16, as we have it there. Not 1000, it is 6. Bits. So that is actually how you can go about that. So I'm going to actually, let's say, I'll leave for you these other values or these other 2 questions. You actually try them for me, because I've even already given you the answers below. So thank you for watching. It's actually been Henry the Computer Guy, and I urge you to please subscribe to my channel, and if you have those friends that actually haven't seen it, you can share the link to them, and they also enjoy what we are actually enjoying. So bye bye, see you in the next video. I sign out.